Hello viewers, welcome to my channel KK Concepts of Electrical Engineering. Wave propagation in a conducting media. As I already studied, that loss tangent, that is sigma by omega epsilon, plays an important role in deciding whether a medium is conducting or non-conducting. For good dielectric, sigma divided by omega epsilon is less than 1. But for good conductor, sigma omega epsilon is greater than 1, since the conductivity sigma is high. We have gamma equals to square root of j omega mu sigma plus j omega epsilon, from which j omega mu, I'm taking sigma out, then 1 plus j omega epsilon divided by sigma, and from which we can write square root of j omega mu sigma of 1 plus j omega epsilon by sigma whole to the power of 1 by 2. This is our gamma. So we know that for good conductor, sigma by omega epsilon is greater than 1, then omega epsilon by sigma is less than 1. The approximate value for this gamma equals to square root of j omega mu sigma. This we can write as square root of omega mu sigma of square root of j. We know j equals to 1 at an angle of 90 degrees. Then square root of j equals to 1 at an angle of 45 degrees. Then we can write gamma equals to square root of omega mu sigma at an angle of 45 degrees. Graphically we represent that. Let this be alpha, and this is our beta, and this is our gamma. This is 45 degrees. Then from this figure we can say that alpha equals to gamma cos 45 degrees and beta equals to gamma sin 45 degrees. Then we can write from this alpha equals to beta equals to gamma is square root of omega mu sigma divided by cos 45 is root 2. Since alpha is quite high for a good conducting medium, attenuation is large and the amplitude of the wave decreases. Now, the velocity of propagation of v is equals to omega by beta, and where omega is fixed one, v is proportional to 1 by beta, and beta is quite large. It is evident that in a good conductor, velocity decreases. Let us solve one more problem. A plane wave of 16 GHz frequency and E equals to 10 volts per meter propagating through the body of salt water having epsilon r is equal to 100, mu r equals to 1 and sigma equals to 100 moles per meter. Determine alpha, beta, v and eta, which is nothing but attenuation constant, phase shift constant, propagation of velocity and intrinsic impedance. Now given epsilon r equals to 100, mu r equals to 1, sigma equals to 100 moles per meter, and f equals to 16 gigahertz, and E equals to 10 volts per meter. First, let us know the nature of the medium. For that, consider sigma by omega epsilon. That equals to sigma is 100, omega is 2 pi f, 2 into pi into 16 gigahertz into epsilon is 8.854 into 10 to the power of minus 12 into 100 is epsilon r. This value is equals to 1.1235, which is greater than 1. This value is greater than 1. That means medium is a good conductor. For the good conductor, alpha equals to beta equals to square root of omega mu sigma by 2. That is plus square root of 2 pi f mu sigma by 2 gets cancelled, and square root of pi is into frequency 16 10 to the power of 9 into 4 pi into 10 to the power of minus 7 into 1 into 100. Find this value. This is not about 80 800 pi, that equals to 2513.274. This is the value of alpha and beta. Phase velocity v is equals to omega by beta, that equals to 2 pi f, that is 16 into 10 to the power of 9 divided by beta is 800 pi. This is 0.4 10 to the power of 8 meter per second. Intrinsic impedance theta equals to omega mu by sigma square root of 45 degrees, that equals to square root of omega, that is 2 pi into 16 into the 10 to the power of 9, 4 pi into 10 to the power of minus 7, mu r equals to 1, divided by sigma is 100 at an angle of 45 degrees, that equals to 35.5431 at an angle of 45 degrees in ohms.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share, and subscribe. Thank you for watching the video. Please stay tuned for more videos.